So will the camera stop working this time? It's a long shot, but I changed a setting and it seems to be working. Okay, sorry, I could hear myself from my phone. I'm monitoring the comments there. Okay, so it looks like the camera is working for now. If it froze again, then I'll change it. Okay, Monday Night CAD. First of all, sorry I couldn't make it last week, not weekend. Did it froze? Yeah, it did. Yeah, let's just hide it. Okay, so yeah, I couldn't make it last week, but we're here now and going over the project ideas. I think at the moment we only have one idea that can be done um, in CAD, which is stencils. Stencils for lure painting. There was another idea which was, what was it? A hangers, wall mount for fishing reels, but to be honest, there are many models on the internet already, so I'm not gonna bother doing that. Um, yeah, so we have stencils, but to be honest, when it comes to stencils, I think these patterns, like if we check them, most of these patterns are random and organic shapes, which to be honest, I would rather do in Blender than doing them in FreeCAD or any CAD software. I mean, it's possible. I'm not saying it's not possible, but yeah, I would like to do some random stuff in Blender using masks and then cutting the mesh. I mean, if it's just circles like this, then it's very easy, but most of them are not. So yeah, I would rather do these stencils in Blender. So what are we doing today? Well, I have a UV curing setup for my fishing lures, and it's not great at all, because I'm using UV light projectors that are like 30 watt each, and if you don't put them super close to the lure, then it's gonna take too much time to cure the UV resin. Once I move these projectors very close to the lure, then I can cure it in half an hour, probably even less. So I do have a station, but at the moment it's not very effective. So the plan is to model a new one that where the lights are very close to the lure, and maybe I'm thinking maybe we can move them. Like I can move the light so it's easier to place the lure, and then once the lure is placed, then move them closer. I think that's the plan, and maybe to cover the sides. Yeah, so I'm gonna start uh with the spreadsheet as always. I have the light with me here. Sorry that the camera is not working. I didn't have time to check it with all the interviews, so I'll fix it at some point, I promise. But for now, gonna have to do the live streams without the camera. Okay, so I'm gonna measure the light. I'm gonna start with the light thickness. Let's first rename this. What are we gonna call it? Let's call it the projector params. So the projector params, we're gonna start with the thickness. I'm not gonna do any validations because this is like a personal model. It's 29.6. Is there any thicker? No, that was the thickest point. So 29.6 is the thickness. We're gonna be left with, we're gonna need a couple of params actually. But let's start with width. How wide is this? Ooh, it's wider than my calipers. How am I going to measure this? Oh. Wait. So that's 150 till this point. It's okay if it's a bit wider, but I'm measuring about 180. So I'm gonna put 180 here and then I can change this later. So we have 30 by 180, and then I mean, this is enough just to place it in something, but to make it secure, there's some sort of a, what is it called? Like a slot or something. And maybe we can model a peg that would go into it. Then it will be secure. So let's see. What are we gonna call this? So we have a slot diameter, let's say diameter, and it's a 9.5 mil in diameter. Now we have a slot width of 22. Wait, that's very tricky to measure. Okay, 21.58. That's our slot width. And we need to know how far back is the slot. So that's gonna be 11.5. That's gonna be the slot. Let's call it offset. Okay, and what about the height? So the height is 130. Okay, so let's quickly create a body. Oh wait, before we do that, we need to give these some aliases. So thickness, width, slot diameter, slot width, slot offset, and height. What are you making today? Okay, so we're making a UV curing station for my resin lures, or not resin lures, for curing the UV clear coat of my lures. There's something wrong here. I don't know if you guys are experiencing any quality issues, but it's telling me that the current bitrate is lower than recommended. Huh. I think this also happened the last time. Bitrate at 30. This is very confusing. I don't know what's wrong with my computer lately. First, the camera is not working. And now this looks fine, at least 720p quality. Yeah, I don't know what's wrong. Anyways, yeah, so I'm making a UV curing station. I already have one, but it's not great. And the reason for that is because I have two UV lights and they are far away from the lure. So I want to make a station where I can move the lights around. So I can, for example, move them back so I can easily insert the lures without touching everything. And then once the lures are in position, then I can move them closer to the lures. Something like this. I don't know how I'm going to do that yet, but let's see. So first thing I'm gonna do is model the actual projector, just so we can have a visual representation of what's going on. So this is gonna be a very simple sketch. I'm going to create a rectangle, starting from. The reason I'm thinking about where do I start from is because this is not gonna be the actual model. But anyways, we can move it around. It's fine. So I can start it at the center. Center rectangle, something like this. Cool. And this one is right here. Okay, great. So the width, this is gonna be the thickness. Cool, trying to get into modeling first few weeks, been tough to say the least. Yeah, so this is different from 3D modeling. So this is gonna be 3D CAD. I don't know if you used CAD before, but CAD is basically all about the numbers and functions and stuff. It's more for creating parts than models, like actual parts that you would manufacture or 3D print or stuff like that. Yes, Blender. So Blender and CAD, they're both complicated, but each program is complicated in its own way. So CAD is more math and spreadsheets and stuff like that. And Blender is more features, a lot more features. So what do we need here? We need the thickness. Okay, so what I usually do is I create a spreadsheet like this one, and I measure the actual values of my, for example, right now I'm measuring the projector. So it has like a thickness, a width, a height, all these stuff. So I place them here. The reason I place them here is, and this is the cool thing about CAD compared to Blender and stuff. Yeah, the user interface is easier on Blender in my opinion. Sorry. Yeah. Blender is definitely has a better user interface than FreeCAD. So FreeCAD is a free open source software. It's not the best. It's definitely not the best. There are better options out there, but they are mostly paid unless you are not doing any work that will make you money, then you would need to pay for a license. But otherwise, it's free for personal use. FreeCAD is free for everything, so you can do whatever you want with it. Yeah, that's why I'm using it. I don't want to deal with licenses and stuff and copyright. Anyways, so yeah, I define all these, and then later, let's say I figured out, oh, the thickness was wrong, so I can just modify this, and the entire thing will be updated. That's the amazing thing about CAD. It's called parametric modeling. Not all CAD software are parametric, but most of them are. What was this one? So this was the height, I think. This is our height. It's not very high. It's more of a Huh. Okay, I think I did it on the wrong axis. This is the width. Okay, sorry. This is the width, not the height. Okay, cool. And now we pad the height. Yes. And you don't actually need spreadsheets for CAD, or you don't have to define any parameters. I can come to the pad here and just instead of defining a parameter, I can input a number here and it should be fine. The reason I use spreadsheets is it makes it easier for me instead of typing this number everywhere across, because you're gonna see we're gonna create a bunch of objects, like 4 or 5 objects, and I might need this number in all of them. So if I later decided to change this number, I would have to go to each one of these places and change it. That's why I like to have parameters here, so I can just change it in one place. Okay, so that's the basic shape of our projector. Now we need to add the slot that we have here at the bottom. So to do that, I'm gonna create a sketch on the XY plane. I'm looking at the top, so I'm gonna look from the bottom. Wait, just so I'm not confused. This is the top. We wanna go this way, so the slot should be offsetted from this face here. Okay, let me look at it. Yes, I measured the offset from this face right here. So I think I'm gonna change something. Okay, so here's the thing. Also, why I like CAD. Let's say I want to move this thing. All I have to do is just delete this constraint, for example, and I want to center it now. So I'll take the center of the rectangle, the origin, and add a coincide constraint, and then this will update everything. So now everything is centered. Now going to the bottom, I want to create a slot here somewhere. I think we have a slot. Yes, here it is, create slot. Something like this. This is exactly what I have. So to center this, I'm gonna take this point, and this point, or this line, sorry, and create a symmetry constraint. So now, basically this line cuts these 2 lines in the center. And now we need to first define some stuff like our diameter. This is our slot diameter. What else do we need? We need to basically put this somewhere. What else did we had other than the diameter? We had the width and the offset. Okay, so the width, basically what I measured is from the top up here to the top down here. That's the width. But here we cannot define this. I can only define the distance between these 2 points, for example. So this is gonna be, whoops. Oh, come on. Yeah. I hate navigation in FreeCAD. Let me just put this here. I'm gonna take these 2 points and I'm gonna set the vertical distance to be our slot width. But again, slot width is everything from up here to down here. So we need to remove from it this radius, and we need to remove this other radius. So 2 radiuses, so basically we need to remove the diameter. We need to remove this slot diameter. And this should be it. Now, how far away... Sorry. I also measured the distance between this point and this edge right here, which is, I called it the offset. So the offset is going to be the distance again between this point and this edge, but I don't have anything on this edge, so I'm gonna use the origin to set the distance. And this distance will be, whoops, what am I clicking? This distance will be, the entire thing is thickness, but from the origin up till here is thickness divided by 2. So if we do thickness divided by 2 and then remove from it the, what was it? What did we name it? The offset. Then we should be fine. Now it turned green, which means it's fully constrained. So we're good. And actually I forgot to measure one more thing, which is the depth of the slot. So let me do that real quick. And let's open it here. Let's call it slot depth. And this is 3.5. Okay. 3.5, we need to give it an alias. This is slot depth. And now we can pocket it. Sometimes you need to reverse it for some reason. And then the distance is our slot depth. Cool. So that's our projector. I mean, the projector has a lot more details than this, but this is all we need to make a stand for it. Reima, hello, what are you making today? I hope I pronounced your name right. We're making I'm basically creating a new UV curing station for my UV resin. When I coat my lures with UV resin, I need to cure them with the UV light. So what I did is currently I modeled a block, like blocking shape of my projector. So this is how it looks to a degree. Of course, it has all kinds of other details, but this is what I need to create like a stand for it. It has a slot like this at the bottom, so that's a good place to secure it somewhere. So the plan is, if I can create a stand here and then a stand here for my other projector, then I can move them around. Like, let's say I move this backwards, place the lures here somewhere. I need to model something to put the lures on, and then move it back in place. And the reason I'm doing that is because the projector has to be very close to the lures for the UV resin to cure fast, or else it will take hours. So let's call this projector. Cool. So now we need to create projector stand. And for that, we might need a new spreadsheet. Let's create a new one. Let's call it stand params. So I need thickness and I need tolerance. Let's say the thickness is 4, tolerance 0.16, for example. We can play around with these later. This is going to be thickness. This is going to be tolerance. And now I can model it. Now, first of all, let me view this origin. Or not this origin. Let's create a new body in part design, and let's call this one the stand. let's see this origin where it is. So this is where the stand is. What we can do is I want some tolerance here, so I can move this up. So I can go to the projector, to the placement. Do we move the projector up or the stand down? I think it doesn't matter that much. Let's move the stand down. So in the z-axis, I'm gonna move it by minus projector params. No, not the projector params. The stand params dot tolerance. So now we should have, yes, we should have a space between the two. And also we need to, yeah, I think that's it. Are you planning to make it closed box or open? I think I will make it a closed box, because this way I can add some like aluminum foil to the inside, and maybe we can also create a lid with a handle, and also put aluminum foil in it. So this way it cures even faster. I think. I don't think it won't actually cure faster, but at least the light will not spill to the outside if you're doing something that's sensitive to UV light. Like for example, if I got a UV resin printer later, a resin printer, then I don't want my UV light to ruin my prints. So maybe we'll make it enclosed. Let's see. Yeah, so let's model the stand. Basically, the stand is gonna start as, why is this on the top? Oh, that's weird. That's a cool bug, because this is on the bottom, but it's showing up on the top. Anyways, it's gonna be a box, and then we're gonna cut something from it. So let's model it quickly. I'm gonna create a sketch here. So this is gonna be exactly the same thing, which is gonna be a center rectangle. But the only difference here is we're gonna add some stuff. So we need to add the thickness and the tolerance to this. Let's see. So this is our thickness, right? So we need to get the projector params.thickness first. And this will basically be the thickness of the projector. And now we need to add to this the stand params.thickness, but we need thickness from this side and thickness from this side. So we need to multiply by 2. And we need to do the same for tolerance. Also multiply it by 2. Now, one thing you can do, instead of typing these everywhere, we can like create them here in the spreadsheet, but it's fine. We need to do the same here. Is going to be projector params.width plus stand params.thickness multiplied by 2 plus stand params.tolerance multiplied by 2. So that's going to be the total thickness and width of our stand. As you can see, the distance between this line and this line is going to be thickness plus tolerance. Now we can model it up, but I need the height. So let's create the height. What did I do? Height, okay. Let's set it to 30 or something. We can always change it in the spreadsheet and it will update in the design. So we need to pad this up by spreadsheet or stand params dot height. Cool. What else do we need? We need to, at the moment, this is solid, so we need to cut from it. So to cut from it, let me first check something. Okay, cool. So to cut from it, we can start cutting from, we need to go up by tolerance and then thickness and then start cutting, right? So to do that, I'm gonna create something called a datum plane, which is basically, let me hide the projector and let me hide the pad. We're gonna move this plane up basically. So I'm gonna create a datum plane, attach it to the XY plane, and then move it up by stand param dot tolerance plus stand params dot thickness. This way we're gonna have thickness on the bottom also. I mean, one way we could have done it, like if you want to do it in another way, is to cut this entire thing and then add thickness on the bottom. But then the total height is going to be different. Anyways, so on this datum plane, I'm going to create a sketch right here and draw a rectangle. This is going to be our projector params dot thickness. Here we only need to add the tolerance. So stand params dot tolerance. We don't need the thickness. And here we need the projector params dot. Did I multiply the thickness by 2? I don't know. I'll check. Width plus stand params dot thickness. We need to multiply by 2. Did I? Wait, there's something wrong. Multiplied by 2. What happened here? Not thickness, tolerance. Okay, cool. Cool. Now we can pocket it. We need to pocket through all, but at the moment it's going downwards, so we reverse it. Nice. Click OK. And now we have basically a slot, and we also have some tolerance. We should have some tolerance. Do we though? Huh. Let's see if I click. Oh, we do. I don't know why it doesn't show up when I look at it from the top, but yes, we do have tolerance. Cool. The only thing left to do is we need to model something that will go into this right here. We need to model this slot. So, okay, what's in here? Why is it doing these weird stuff today? But looking at it from the side, huh? Oh, wait, my bad. Okay, my bad. Yeah. This is not the way to go. So I am going to delete this datum plane. Now this right here is gonna break because this sketch, it was attached to the datum plane. But now we need to support it by something else. Okay, cool. So let's support it by the XY plane, 0, 1. And now if we redo this, we need to pocket. We don't need to reverse it. Okay, so what I did now is I messed the entire thing. Through all, okay, can we? pocket one. Oh, okay. Okay, now it's working. So what I'm gonna do is I'm gonna remove the stand parameters dot height. No, not height. Thickness. I'm gonna remove thickness from the height and then we re-add it at the bottom. So we need to re-add the thickness here at the bottom, which shouldn't be that hard. Just click on the bottom plane, create a rectangle again, which will be, that's why you would need these probably in a spreadsheet. But it's fine. I think it will only repeat 2 times, I think. So width plus stand params dot thickness multiplied by 2 plus stand params dot tolerance multiplied by 2, and then the width is going to be projector params dot thickness plus stand params dot thickness multiplied by 2 stand params dot tolerance multiplied by 2. So now we have exactly the same outline. Should be exactly the same outline. And we can pad it downwards by stand params dot thickness. Cool. So now we have this. Now we can add the pocket or this socket. So also on the XY plane, we need to do something similar to what we did on the projector. So we're gonna create a socket, make it symmetric on the x-axis. Now here, when defining the diameters and the width and everything, we need to add some tolerance, or we need to remove some tolerance from the values, because this is gonna be like the peg that will go into the hole or the socket. So it needs to be smaller. So from the projector params, we have something called interesting. What did I call it? Why can't it find it? Projector params slot. Called it slot, not socket. Projector params dot slot diameter, but we need to remove from it the stand params dot tolerance multiplied by 2 because this is a diameter. Okay. This is a diameter, true, slot diameter minus tolerance. Okay, cool. Cool. Now we need to define the width, I think I called it. And the width is going to be the projector params dot slot width. Basically exactly what we did there, but so here what we did on the projector was did the slot width minus the slot diameter, because when I measured the width, I measured from up here till down here, but now we're defining the distance between the center. So if we did this is exactly what we did there, but we need to remove the tolerance. So we need to remove stand parameters of tolerance multiplied by 2. Now, when we're defining this value, we need to also take into account the tolerance, but in which direction? The tolerance has to be in this direction, basically towards the center. So the way we defined it there was we took the entire thickness of the projector divided by 2 because we're coming from the center. So we're only going half the thickness. And then we removed the stand parameters dot, I think I called it slot, not stand parameters, no, projector parameters dot slot offset. So now we're exactly at the beginning of the slot, but we need to also remove one tolerance, basically. Stand parameters dot tolerance. Interesting. Okay, I definitely did something wrong. Give me a second. What did I do here? Thickness divided by 2. Oh no, did I do? I think. Wait, let's check. We can check. Now we can pad this up by projector params dot slot depth minus stand params dot tolerance. And let me show the projector, and then what we can do is enable transparency on here. Set it to like 25 or something. And let's look at it from the bottom. Okay, so okay, there is something wrong, is there? I feel like it has more tolerance here than in here. Or is it because of this shading issue? Let me check this real quick. Let's check the diameter first. Okay, this is fine. And this one, so we did the slot width minus slot diameter minus tolerance multiplied by 2. No, I think it's fine. I think it is fine. It's gonna work. If it didn't work, then I can just like increase or decrease the tolerance here, and it should be fine. Let's get back the transparency to 0. So that's, let's say, one of the stands. Now, I think I will add more stuff to this to make it stable. But for now, let's assume this is the stand. We need to put it somewhere, and it has to be able to move back and forth. So we need to create some sort of a box where we have 2 of these that can move left and right. And what else? And there's a place at the top where we can hang lures. So let's say we can hang 5 lures, for example, and then, so move these to the side, hang the 5 lures, and then move them closer. Maybe we can have rails. We'll see. So for this, we need to create a new spreadsheet. Let's call it the box params. And we need width. We need width, height, depth, width, height, depth, thickness. I think these are for now good enough. Now the thing is, we need to add some constraints to these, because if we're looking at from the top, let's assume this is the width of the box and this is the height of the box. Now the height cannot be smaller than this. And I'm also thinking if thickness is included in the total width or not. I don't think it is. So let's say thickness is 4, for example. So if width here is 150, then the total width is going to be 150 plus 8, something like this. But the width itself is the internal. So it's what we're worried about at the moment regarding this. It needs to fit the stand, right? So we know the total width of the stand. We can actually calculate it here somewhere. So the total width of the stand is going to be it's going to be the projector params dot width plus the plus thickness multiplied by 2 plus tolerance multiplied by 2. We can call this total width. We can do the same for the height, but this is what we're worried about at the moment. Let's call this total width. And now we can use this value in the box params to set a minimum value here. So the minimum value, to set a minimum value, we'll use the maximum parameter. I know it's inverted, but that's how it works. So the maximum value can either be not like this. Wait, let's call this width input. So this is what we input here, but or we can do W input so we don't get confused later when we're typing. And the actual value of the width is going to be the maximum of width input, or we can get the value from stand params dot total width plus, let's say, 20. Yes, so even though we added 150 here, the actual value is going to be this, because we cannot go lower than this or it will not fit. So I added some padding, like 20 mils. Maybe we can add even more. We'll see. This is gonna be our width. So height, is it width or height? I think. Okay, let's call this width. I'm looking from the... Yeah, I already named this width. I know it doesn't make sense, but this is already called width. So I'm gonna stick with width. Height, let's do... We can also set a minimum value for this, but it's fine. Height. Oh, come on, what's wrong today? Why am I typing height like that? Depth. Depth is gonna be like the depth of the box. So do we need a minimum value for this? I guess we should, but for now, I'm gonna set it as 200. We can change all of these whenever we want. Thickness. Cool. Cool. So now we can start modeling. Let's go to part design, create a, we need to not select anything, then we can create a body. Let's call this one the box. And we can start by creating a sketch on the XY plane. Did I do it on the XZ plane? Yeah. Let's delete that. Create a new one. XY plane. Cool. Where's that option? Right here. Nice. And also I'm gonna do it centered. So we said this is our width. This is our box parameters dot width. And this is gonna be our height. Again, I know it doesn't make sense, but I should probably rename these later to something that does make sense. As you can see, we have some padding here, which is 20, so it's 10 on each side. 1 centimeter on each side. It should probably be bigger. We'll change it later. And we also have a depth. Now this, where does it start? We're gonna move this later, so it doesn't matter at the moment. And we're gonna pad up by box params dot depth. Cool. Now I'm gonna try one thing. If I do a thickness here, can I do it on the outside? I think by default it adds the thickness on the outside. Like if I do 20, yeah, by default it does this. So all I have to do is just do box parameters dot thickness. Cool. Now I'm not worrying about anything at the moment, but I should start to worry about how to attach this thing to the box. Or should I just leave it like this? Or maybe, maybe I can just add, no, never mind. Never mind. I think I can add rails that these can move on. Something like this. Let me think about it. But first, if we check the box, let's make it transparent for a moment. 25 or 30 and look at it from the side. You can see that this projector and this stand, we need to move them up, or we can move the box down. So this value right here is this value right here is thickness of, I think, of the stand. Let's see. I'm gonna go to data, placement of the box. Let me see the placement of the stand. Stand is minus 0.16 and the projector is 0. So the box we can do, and the Z minus stand dot tolerance minus stand params dot thickness. So now it should, yeah. Now it's exactly at this line. Cool. Nice. We need something to let the lures hang. But first, one by one. Let's tackle them one by one. Let's move this projector and stand on the x-axis by box params dot what did we call this, height divided by 2, let's say minus 10 minus, or let's say minus 50. I'm gonna copy this. Did it work? Interesting. I had to make it negative. So minus, and this one is plus. And I'm gonna do the same thing here. Okay, cool. I still don't know how to move this left and right, because I can do a print in place thing, but I don't want to do that because if something breaks, then I would have to replace the entire box, which is going to be a pain. So I want to somehow just insert this from the top and place it on something that will keep it in place, but still at the same time can be moved left and right. So let me hide the stand and projector for a moment to see how we can do this. We can technically create a sketch. Here, no. We can do it here, but are you going to print them in closure too? You mean the what is it called? You could use metal strips and magnets. Interesting. You mean metal strips and magnets for the stand or for the what do you call this? What do you call the top piece? I forgot what it's called. Oh my god. For the stand. No, I don't wanna overcomplicate it with magnets. We can use magnets for the top here. Like if we can place 1, 2, 3, 4 magnets and then 4 magnets on the lid. I just remembered the name, it's lid. Then it will keep it in place. But for the bottom, for the stand, for this stand, I think what I'm gonna do is actually very simple. So let me create a datum plane. Let's not select anything at the moment. I'm gonna show the origin and select this. Then in the Z direction, we need to set the value to the thickness of the box. So technically, wait, why is this wrong? What? Oh, the XY. Right. My bad. We did the thickness inwards, so, or outwards. So the XY plane is already, it's already on the bottom here. So I can create a sketch on the XY plane. And what I'm thinking is basically just something like this. Something like this till here. So we can't move too much. Maybe till here. And then we can do an array to create, let's say, 4 of these. But then the problem, how do we place the stand here so it doesn't move up and down, because it could tip, it could tilt this way and ruin the lures. So yeah, no, it's more complicated than what I was thinking. But also, how do we keep it? Because as I said, I can do a print in place. I can print the box with the 2 stands in the same place, and they can still be moving left and right. But if the box break, or anything break, like the stand broke or the box broke or something, I have to reprint the entire thing, which is a waste of money. We can do something where we have a print in place, but we attach the stand to it using what is it called? Using screws and nuts. This will work, I think. So it will look something like, we have something here, let's say a square. and this is going up, so we need a cutout. We need to cut an area from here, and then there's some sort of a square that goes, if we look at it from this side, it goes from here, it goes into the plastic this way and then up this way. So it cannot move up or down. It's restricted in in these two directions, but it can move this way freely. And then we can screw the stand to it from two places, let's say from here and here, and then this can move left and right. I think this will work. This will work. But 4 mil is too little. So maybe we have a thickness for all the sides, but for the bottom we have a different thickness, because I need more than 4 mils on the bottom, and I don't want to print like 10 mils here for no reason. It's just wasted material. So let's delete that sketch, we don't need it, and I think I'm gonna delete the thickness too. Yeah, I'm gonna delete the thickness. So basically now we're right here. Cool. Cool. So now we can recreate the thickness on the sides by doing a sketch on the XY plane. And then starting here, we can do the box params dot width minus box params dot thickness multiplied by 2, and then the same here, box params dot height minus box params dot thickness multiplied by 2. Now we can add fillets, but I don't think they're necessary. So I'm just gonna cut. We can add the fillets later also. So this is through all and reversed. Cool. Now let's define a bottom thickness. I mean, the idea of having metal rods is not bad, or metal strips and magnets and whatever, but I don't want to overcomplicate this this model, this specific model. Bottom thickness, let's go for 12, and again we can change it whenever we want. That's the beauty of CAD. And now it's as easy as just drawing another rectangle and extruding it. By the way, we can click this external geometry and then add these lines, but I try not to do this to make it completely parametric, and so that there is no way this is gonna break, because it could break. Box parameters dot height. Oh, the only thing that changed now is that the thickness is inwards instead of outwards. If you add wings to the stand and slots to the walls of the box, the stand could slide back and forward, but be supported so it won't fall over. Huh. Interesting. Interesting idea. You mean something here? Let's say let me just make sure I understood what you mean. We add wings to the stand and slots in the wall of the box so the stand can slide back and forth. So by wings, you mean in the stand itself, there's something going out like this, one on this side and one on this side. And then there's something in the wall that support it. Then the stand can be twisted into place. So the stand, you will put it diagonally and then twist it sideways to go. But the problem with this is the printability now becomes hard because the stand, let me just do it like that. You're gonna print the stand. How do we hide the box? I'm gonna print the stand on this face down and then this up. If I put something here, then we need lots of supports and stuff. But it's doable. However, it will not keep it in place fully. It can, since you can twist it in, you can still twist it and it will fall off. Like twist it by mistake when you're moving it. Something like this. Let me just try my idea and then we'll see. I don't know if you got the idea or not, but let me show you what I mean. So here we have width. But yeah, now I have a small problem that we're going inward instead of outward. But I'm gonna max. What I can do is change the add the thickness here. So add stand the total width plus thickness multiplied by 2. So this is 216 now. I think this will fix my issue. So this sketch, we can pad it downwards by box dot bottom thickness. So now we have enough material to do a print in place. So this print in place, it's gonna have some parameters also. It's gonna have a width and height. Let's do something here. Let's call it a rail. So we have rail width, rail height, and I want the printing angle. I'm gonna call it the printing angle because I want this to be something like 45 degrees, so it's easily printable, or maybe even less. And I think for tolerance, let's do a rail tolerance. Let's keep it different than the other ones. Rail width, rail height. Cool. Let's do, I don't know, 10 by 15. Let's see, rail width. This one is rail height. This one is printing angle. And tolerance, let's do 0.2 for now. Rail tolerance. And we're gonna do 2 rails, not 1. So maybe we need the position of the rail also. Like, where is it? Is it here or here? So we can do rail. Let's call it offset. And let's do it at 40 for now. I can change it. So rail offset. Cool. Cool. So this rail, we need to create a new body for it. So let's do that. Let's create a body. let's rename this to rail. And it's a bit trippy, sorry. The origin is currently where it's not at the top. And that is because we moved. What's going on with my mouse? Okay, now it's working. Because we moved the box by this amount. So I need the same amount for the rail. So now I want the rail to be in the middle of this box. So we need to also remove box parameters dot bottom thickness divided by 2. Now we're in the middle. And now I want to move it to place. So I want it to be first of all, we defined an offset on the y-axis. So on the y, we're gonna get this from rail offset. So it's gonna be here. And let's put it under this. And where did we put this stand? On the x-axis. Let's copy this. I should probably put these in a spreadsheet. Okay, cool. So now I need to create a sketch right here. So that's my center. Cool. That is my center. What we need is, let's start with the rectangle. And this right here is going to be our rail width. And this right here. Oh, wait. Do we need it in the center? Do we need it in the center? Yes, we do. Because we don't have a rail depth. The depth is going to be whatever the depth of this is. But what we need is, so this height here is going to be exactly the same as this height, which is the box parameters dot bottom thickness. And now we need to do something like this and this. Okay, cool. And now we need the angle. So the angle is going to be, first of all, let me make this clearer. The angle is going to be between this, and it's our box parameters dot printing angle. And we can also define it here, or I can take this point, and the y-axis and make it, or is this z-axis? Z-axis, I think, make it symmetric. So I don't need this line. If I delete it, yeah, what if I trim it? Is it the same? I guess I can just keep it and make it construction geometry. This one, make it construction geometry also. Cool. Okay, so this is going to be our rail. We need to pad it in this direction, so let's do that. And this is going to be our box params, the trail height. But I think we can make it symmetric, yeah. So we can center it. Cool. So that's our rail. So the plan is there's going to be a cutout that looks similar to this. And then this can be attached to our stand using a screw. And then there's going to be a nut inside of this rail that will hold it in place. Now what is left to do is create the cutout and also we need to place the hole for the nut and then the hole for the screw. And if we mirror it on this plane and then mirror it on the other plane, then we're gonna have 4 cutouts and 4 rails. Okay, cool. Let's go back to the box. Toggle active body. And now we need to think about how big of a cutout we need. I think we can start from here all the way just before the middle. And then maybe we can stop it somewhere so we can't accidentally smash the 2 lights together. So to do that, we need to create a sketch somewhere here. Let me show the origin again. Okay, cool. So we need to start from somewhere. Maybe we can start with the end position right here. And the end position is basically going to be the distance between this right here and this edge right here, and maybe a bit more padding. So I'm going to create a datum plane, attach it to this plane right here, and let's see. In the Z direction, okay, we need to go in the negative Z direction. So how much do we need to go? So minus, how much do we need to go? This is our stand total width. I think we have, we have the total width, but not the total height. We have a height, right? We have a height. No, not the stand params. We get it from projector params dot. We have a width. We have a height. No, not a height. What did I call it? Projector params. We have a width. Height 130. Thickness. Okay. Yeah, sometimes these names can get confusing. Projector params dot thickness. Okay. Plus stand params dot. So first of all, this is a thickness divided by 2. We need to divide it by 2. Okay, let me do this. So stand params dot thickness multiplied by 2. So this is the entire thing at the moment. The entire thing. Then we divide this entire thing by 2. So I'm gonna add brackets here. So we divide this entire thing by 2. And then I need to remove from it basically what I have here divided by 2. So that's the box params dot rail width divided by 2. And then, so basically what I have now is it's gonna stop exactly at this line. But I want to add a bit more. So let's add 1 centimeter. Okay, cool. So this is where this thing will stop. Yeah, this way totally work. I just think friction fit would allow toolless adjustment. So friction fit. The thing is, so this tolerance we can change. Projector params. So I kept this tolerance different, unless you're talking about something else, maybe. And I didn't get you, but oh, you're talking about the twisting thing. I want it to be easily movable. Now I'm not sure yet if this is gonna be easily movable or not, but let's see. So let me hide everything and now we can create a sketch. So here I want to add some tolerance. Let's do this. Cool. Cool. So we need to add a rectangle here somewhere. So we need to get this center point in place. Let's see. This was our box params dot, what did I call it? I think rail offset. Yes, cool. We got the center right. Now the height, the distance between this point and this point is going to be this thickness divided by 2, which is our bottom thickness divided by 2. And now we have this, which is our also bottom thickness. But here we need to add the rail tolerance multiplied by 2. So we have tolerance at the top and tolerance at the bottom. And here I think also the same. So I'm gonna take this. What did we call this? Box params dot rail width plus the same thing. Box params dot rail tolerance multiplied by 2. Okay, cool. Now here we don't have a line. So I'm gonna create one. And this is going to be our construction line. So let's give it a width just so that it doesn't complain. And this is, let's just do the width of the box divided by 2. It doesn't have to be just put it here. This is going to be a construction line. And let's put it in the center. So this line has to pass through this point. Cool. Nice. Now everything is fully constrained. Now we can redo the lines. So from here to here, and then from this point to this point. From here. Oh, what's going on? I don't know why it did that. Interesting. What is this constraint? Never mind. That was weird though. Okay, and now we can constrain the angle at box params dot rail, not rail. It should be rail, but I named it printing angle anyways. And I can take this point, and oh, we don't have a line of symmetry. Let's just add another angle here. Ah, come on. So if this is 45, then this is 180 minus box params dot printing angle. Cool. Nice. So this line and this line are construction. And then if we close, Nice. This is gonna be our cutter. So now we can cut. Now how much do we need to cut? Let's see. We need to pocket. How much do we need to cut? Interesting question. I'm gonna take, I think for this, I need the calculation that we did here for this plane. So we took the thickness minus the tolerance. Plane width divided by 2. So this relies on okay, I'm thinking if I can use this, but it's gonna be a very big it's gonna be a very big formula if I'm gonna take this and use it there to get the end. But I think for now, just to make this simple, let's just use box params dot, was it height or width? I keep getting confused what I did. Yeah, no. I know this doesn't make much sense, but it gives it at least a bit of room to go back so I can insert the lures. That's all I need. I don't want it to go all the way anyways. Now what we need to do is we need to take this cut and we need to repeat it 4 times. So one here, one here, one here, and one here. And there's a really easy way to do that. The thing is, if I do a mirror on this plane to mirror it here, I can no longer mirror this to the other side. Let me demonstrate this. So if I did this mirror and click OK, if I take the mirrored feature and try to mirror it, it's gonna show me an error. And I think I should save now, just in case. So let me just go to desktop, free CAD, create new file. Let's call it UV station. Cool. And let's call this UV state. What did I type? Okay, cool. But why did it look like this? I don't know. Usually it looks different. Anyways, I'm gonna select the pocket and I'm gonna use something called a multi-transform. So with this multi-transform, what we can do is we can select a feature or actually multiple features. So if you did like a pocket, then a pad, then did multiple things, you can select them all. And then we can do multiple things with these. Like, for example, I can add a linear pattern here and then take that linear pattern and mirror it, stuff like this. But for now, I'm gonna add 2 mirrors. So the first mirror is gonna be on a vertical sketch axis, and then I'm gonna add another mirror, but this one is gonna be on the what is it called? On the XZ plane. Something like this. And why didn't it work? The first mirror is going to be, oh no, not the XZ plane, the YZ plane. Wait, I'm gonna select this, and this is on the YZ plane. Okay, cool. And this is on the XZ plane. Nice. So now we can do 2 mirrors. Now I only have 1 rail, but we can easily create 2 by adding clones, or 4, sorry, by adding clones. But I'll do that at the end because I still have some stuff to do with the rail. So what I need to do here is let's hide the box because it's not required in this step. So I need to add a slot here for a screw, and then a slot here for a hole for a screw, and a slot for the nut, basically. So we can insert the nut from the bottom and then hold it for using a screw up here. And I don't think I need any parameters for this. I mean, I can add them, but it's not necessary. I'm gonna start with the stand, just making sure this starts from the center. Cool. And I'm gonna create a sketch on the XY plane. And what we need to do is just add a simple circle that is, I'm using M3 screws. Should we make this a parameter? Maybe we can add a spreadsheet called fasteners. But you get the point. I'm gonna leave it like this for now. You can always come back and change these to parameters. Now we need to put it in place. So from here to here, it is going to be dot offset. Yes, that's it. Nice. So now we just need to pocket this and set through all. Cool. So the stand is done. Let's just hide it. And now we're gonna work on the rail. And let's create a sketch on, okay. So here we need to do some stuff. Let's show the body. We know the height, and I want the hole to start from, or wait. The hole for the screw is gonna go all the way, but the nut is gonna have a different thing. So let's do the screw first. Start from here, and then just create a simple circle. Again, this diameter is going to be 3.2. Yeah, definitely I should add it to a spreadsheet. It's just because of the time. I want to finish early. So I'm gonna pocket this through all. Let's do, so to pocket this all the way, I'm gonna do it using a dimension and set it symmetric. And basically we need the entire thing. So let's do bottom thickness, and it's gonna cut it all the way. Julian Martin says good night. Thank you. Good night to you too. I'm gonna sleep in a bit. It's already 11 p.m. But let's try to finish as much as possible. Yeah, I need to add a datum plane, attach it to the XY plane, and I want to move it up to basically where I want to place the nut. So if we go in the Z direction, let's leave 3 mil or 4. No, not 3 mil. 3 mil I think is too much. Let's leave 2 mil of material at the top. To do that, we can get the bottom thickness divided by 2 because we're starting from here. Now we're at the top, and then remove 2 from it. Okay, nice. So it ended up at 4. Cool. And now we can hide this. Let's create a sketch here. And for the nut, we need to create a hexagon like that. Now the thing is, I think I had a nut around here. Just give me a second. Let me measure it. Okay, here they are. And where is it? Where did I put my calipers? Oh, come on. Okay, it's under the UV light. And the distance between two of these two edges is 5.43. Now we need to add some tolerance to this. So 5.4, let's make it 5.6. So the distance between this point and this point is 5.6. Cool. And how much do we need to pad it? Let's add some transparency so we see what's going on. I need to pad it downwards or pocket it downwards. And let's measure this also. 2.34. 2.35, 2.34. Okay, so it's 2.34. Oh, wait, no. I can just go through all. Yeah, I don't need to embed this. I mean, I can embed it, but yeah, I think this is better. This will actually add strength to the part when you have things like these inside your part, because the printer has to add extra walls. So yeah, why not? And let's click OK. Cool. No need for transparency anymore, so set it to 0. Nice. So the concept is, this is going to be a print in place. We're going to have 1, 2, 3, 4 here. They're going to print with the box in one print. And then show me the stand. We forgot to do something here. We forgot to mirror this. So let's do that. Let's mirror it on the XZ plane. Nice. Yes, so then we put this stand in place and then just screw it to these two rails. Do the same here. And we should be golden. Now this is not done because once I have to add these 4, which I will do in just a second, but I also need a place to hang the wires from. Not the wires, the lures from. Now I can't just model something that like a rod or something that goes from here to here, because it will not be printable unless I model some sort of a holder here. I think Reima, you explained it as wings. So we can add wings, one wing here and then one wing here. And then we have another 3D printed rod that will get attached to it. By the way, I'm curious about the total width. It's 216. Okay, cool. This is still printable. And then from here to here, it's 200. Okay, nice. And from here to here, 212. This is completely fine for my Bamboo printer, but maybe I should make a smaller version if someone is interested in this, but they don't have a big printer. Good thing is that everything is parametric to a degree. Okay, now the rails, let's clone them. We need 1, 2, 3. And we need to move them to place. So this one, let's see. We were interested in the x-axis. So if I copy this and then come here, if I add this where it will be at the top. So it has to be positive. But now it's gonna be in the, wait, what? Why though? Height divided by 2. Oh, okay. Okay, my bad. And this one is going to be offset. Okay. On the y-axis, we need to get the rail offset and multiply by 2. No, then it's negative. Cool. Copy this. So now here we do this, but we also need the x-axis. Nice. Cool. So now we have 4. So when I export this, I can actually export all of these as one STL file. So I can print it in place. And for this one, I think we just need to mirror it. Yeah. It's already 11:12, so I'm not sure if I attempt to do the last thing today or maybe continue it next Monday. So next Monday, for example, we can add the thing that we hang lures from, and then we can add the lid. And maybe by then I would have tested this this base down here to see if it needs any adjustments. But yeah, I think that's it for today. And again, I'm super sorry about the camera. It doesn't want to work. It's frozen. I'll try to fix it as soon as possible. But yeah, I don't know. I don't want to promise you guys because I'm super busy with also some other stuff. If you have any project ideas for CAD or even other stuff, it doesn't have to be CAD. Like it could be Blender stuff, new fishing lures and new fishing equipment, or anything that can be done in CAD. Join my Discord server. We have a channel for project ideas. You can post your idea there, and I'll try my best to do all of them. And yeah, that's it for today. So have a good night, and I see you on Friday. Friday we have the Friday night Lure Lab, or if you're a CAD guy, then see you on Monday, next Monday. Thank you guys, have a great night, and bye-bye.